To prevent damaging the radios and electrical equipment, the pilot must ensure that they are off prior to testing the standby battery.
Radios and electrical equipment are all off.
Hold in the test position for 20 seconds. The green light adjacent the switch should remain illuminated through the test. Following this test, the switch should be moved to the arm position. Once the standby battery switch is moved to the arm position, the essential bus should be powered. As a result, the PFD screen should power up. Once the PFD has finished loading, the engine indicating system should be checked. The pilot is looking at engine parameters such as oil temperature and fuel quantity. The pilot should also ensure no red X's appear over any of the engine indicating instruments. Please note, other components may have red X's over them. During this checklist item, our primary concern is verifying the operation of the engine indicating system. Once the avionics buses are switched on, these X's should disappear. Essential bus volts. The pilot should verify a minimum of 24 volts are shown. Main bus volts. The pilot should verify no more than 1.5 volts are shown. Standby battery amps. The pilot should verify a discharge is shown. Standby battery annunciator. Illuminated. Alternator and battery master switches. Verify both switches on. Aircraft lights. For flights during the day, both beacon and strobe lights should be turned on. For night operations, beacon and navigation lights are required. Fuel shutoff valve. The fuel shutoff valve should be verified on by confirming the knob is pushed full in. Upon completion of this flow pattern, the pilot must verify accuracy by referring to the printed checklist. The pilot should verbalize each item while visually confirming its appropriate condition or position. For example,
Passenger briefing complete. Seats are adjusted and locked. Belts and harnesses, everyone is secure. Radios and electrical equipment was off. Standby battery, we tested. PFD is on, no red X's. Essential bus volts, minimum of 24. Main bus volts were 1.5 or less. Standby battery annunciator was on and is on. Alt and battery switches are on. Lights, beacon and strobe, and the fuel valve is in.
After verifying the flow, the pilot will announce,
"Before start checklist complete."
This example of a flow pattern demonstrates two key elements. First, the proper procedure for completing and verifying a flow pattern. Second, it illustrates the detail contained in Chapter 1, Expanded Checklist Procedures. This attention to detail is why it is so important to use the expanded procedures in the beginning stages of training as a supplement to the abbreviated checklist. All engine start checklists are do lists and must be completed step by step while referencing the appropriate checklist. During engine start, do not move the throttle while cranking the engine. Such actions may allow too much fuel into the engine during start, thus flooding the engine, or may even lead to an engine fire. Always follow manufacturer guidelines with respect to starting procedures and cranking periods. For the Skyhawk, Cessna recommends limiting starter cranking times to 10 seconds with a 20-second cooldown period between attempts. After 3 cycles, the starter should be allowed to cool for 10 minutes.
Drop clear!
After completing the engine start do list, the student shall commence the after engine start flow pattern. After switching the avionics bus 1 and 2 switches to the on position, the engine must be leaned. Using the amplified procedures in the standardization manual, we know the procedure is as follows. The throttle is increased to 1200 RPM. Next, the mixture is slowly leaned until a peak in RPMs is reached. Finally, the throttle is returned to 1000 RPM. Following flap retraction, the pilot verifies the flow pattern by announcing and visually checking every item while referring to the after engine start checklist.
After engine start checklist, we'll verify engine instruments are good. Avionics bus 1 and 2 are now on. Mixture is leaned and flaps retracted after engine start checklist complete.
Prior to taxiing, the before taxi flow pattern must be accomplished. After ensuring the database is current, set the current fuel load into the totalizer using the MFD soft keys. As a means of gaining proficiency with the auto load feature of the Garmin 1000, the UND standardization manual requires navigation and communication frequencies be loaded from the waypoint page. Next, check the status of GPS satellite reception on the third page of the aux page group. Additionally, all UND flights require a flight plan to be loaded into the flight plan page. After receiving your ATIS information, the altimeter setting can be adjusted on the PFD using the baro knob and also set in the standby altimeter. Prior to taxi, obtain your clearance.
That's affirmed. We do have India 213, standard taxi for runway 17 left, and we'll hold short of Charlie.
After setting in the assigned squawk code into the transponder, verify the flow pattern, then clear the area and commence taxi.
Taxi, fixed release, engine instruments are in the green. Flight instruments are good. They're clear right, clear left, going left. My brakes are good.
Brake effectiveness must be checked prior to taxi. If the brake effectiveness does not satisfy the pilot in command, he or she should discontinue the flight.
I have the flight controls.
And contact maintenance personnel. While taxiing on any ramp, the pilot should be focused on his or her surroundings. Also, a ground speed of no more than 5 knots should be observed while taxiing in congested areas. With so much activity, it is important for the pilot to ensure they are clear of the ramp area prior to beginning the instrument cockpit check. At the pilot's discretion, to enhance collision avoidance during taxi at night or during restricted visibility conditions, any lights may be used to increase aircraft visibility. Once the instruments have been checked, the flow pattern is verified.
Instrument cockpit check complete. Taxi checklist complete.